Hi everyone, today's lesson is on graphing inequalities. The first question here says, what does the inequality that's given here mean in words? Well, it means that y is less than or equal to 3x minus 9. Another way to say it is 3x minus 9 is greater than or equal to y. The hardest part for a lot of students is this symbol here. And it may take a little bit of practice for you to understand what it's saying. I recommend that you say it out loud, and that way you can get used to how it's said, and that way you can understand what it is intending. What is the difference between an equality and an inequality? Well, an equality has just the equal sign. An inequality has this sign here, either a less than or equal to sign, greater than or equal to sign, or just the less than or just the greater than. So you will see this, 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 or this. These are all possible options that you'll see. We're going to graph both the equality and inequality using the following test points to determine what the graph looks like. So you'll notice that in this column, I'm using an equality. And in this column, I'm using an inequality. And I want you to see the difference or the similarities between the two of them. The first one is a test point, and the test point is A, which is 5, 6. So here I would say 6 is equal to 2 times 5 minus 4. That means 6 is equal to 6. That's true. That's allowed. Here, that's 6 is less than or equal to 6. Again, that's true as well. Well, let's say this. I have negative 4 is equal to 2 times 8 minus 4, which is the same as negative 4 is equal to 12. Well, that's not true. And if we tried it over here, we would get negative 4 is less than or equal to 12. Well, that's true too. Let's try the last one. I would get 2 is equal to 2 times negative 7 minus 4, which is 2 is equal to negative 18. Well, that's not true. And 2 is less than or equal to negative 18. Well, that's not true either. So let's see what's happening in terms of the line. Well, we all know how to graph y is equal to 2x minus 4. I start here at the y-intercept of negative 4. I draw a slope of up 2 over 1, so to the right one, or down 2 and to the left one. Hopefully you have a ruler and can draw a really nice straight line. A little straighter than mine is right now. But there you have it. And you'll notice that the point 5, 6, so 5, 6, that's point A, that's on the line. The point 8, negative 4, that's not on the line. And the point negative 7, positive 2, that's not on the line either. So A works, B does not, nor does C. Well, let's draw the inequality. So when you draw it this time, you'll notice that the quote-unquote line is the same, but this time the test points A and B work, and the test point C doesn't. So when we work with an inequality, we are able to do some shading. So when we shade the region that doesn't work. Another way to say it is we are getting rid of this side. Now you may sort of notice that it's to the left of the line here, and then to the right of the line is the region that is okay. Another way to say it is above the line we're getting rid of, and below the line we're keeping. So an inequality is usually a region. So it says here, state the difference between an equality and an inequality and how you graph it. Well, for an equality, it has to be a point on the line. But on an inequality, it's going to be a region, either above or below the line. So like I said, over here in the equality, it has to be on the line. That's the only way to do it. But an inequality, notice that it has to be in a region. So in this case, it's the region below the line. The region above the line is being canceled out. Okay, so let's try another example. This example is a little bit more, it has a different question to it. It says, what about when it is just greater than or less than? So notice here, there's no equal to line. Well, what that means is that when I graph this line here, I'm going to use a dashed line. So let's try it out. I start here with the intercept at 3. And then I go down 1 and to the right 2, down 1 and to the right 2. I can go up 1 and to the left 2. And in order to finish the line, I make sure that I draw a dashed line instead of a solid line. That's how we explain an inequality that is not an equal to inequality. So now I want to find a test point. So I want to pick a test point. Well, if you look at this, you should look and say, okay, what's the best test point to pick? Well, hopefully you said this one right here, 0, 0. 0, 0, when it's not included in the line, is the best test point to pick. So here's how it works. So we say 0, and we say greater than -1/2 times 0 plus 3. And if you want to make sure, this 0 is this one right here, and this 0 is this one right here. Continuing, I say 0 is greater than 3. Well, that's false. That's not true at all. So I want to shade the region that contains the 0, 0. So I'm shading the region below the line. Okay. I've given you a bunch of examples in order to try this out. So if you'd like to try this out on your own and pause the video, you may. If you'd like to do a couple of the examples with me first, and then try the last 2 or 3 on your own, and then check your work, that's great as well. So here we go. First of all, I am graphing this line over here, -4x plus 6. Hopefully you've noticed that this is a dashed line, so make a note to yourself. So I'm going to start here by graphing this line. So I'm graphing my line. I've got a dashed line. This is what it looks like. I'm going to pick my test point. Again, the best test point that I can pick is 0, 0. So I say 0 is less than -4 times 0 plus 6. So 0 is less than 6. That's true. So that means I'm going to shade the side where 0, 0 is not. So 0, 0 is here. That was true, so I'm going to shade above the line. All right, let's try another one here. This is a solid line. So everybody graph. Once you've graphed, you're going to pick your test point. Again, 0, 0 is a great test point to pick in this case. So 0 is greater than or equal to 2/3 times 0 minus 1. That 0 is greater than or equal to -1. Well, again, that's true. So if 0, 0 is here, I'm going to shade on the opposite side. So I'm going to shade below the line. All right, there are 4 more right here. I'd like you to try them first, and then I'm going to quickly walk through them with you. So pause the video, try them out, and see how they go for you. For this next example, hopefully you've noticed that it's a solid line. Now graph. I'm going to pick my test point. Again, 0, 0 here is a great test point. 0 is greater than or equal to negative a half times 0 plus 4. So 0 is greater than or equal to 4. Well, that's false. So if my test point is here below the line, I'm actually going to shade the false region, the region that I want to get rid of, which is below the line. Next one. Hopefully you've noticed that this is a dashed line. Graph. So you've got your dashed line. Notice that the y-intercept is 0 and that it goes up 1 and to the right 4, or down 1 and to the left 4 to draw my line. But because it goes through 0, 0, it cannot be my test point. So another test point I can use is, in this case, 1, 1. 1, 1 is a perfect example. I could use 5, 5 if I want to. I could use 5, negative 3. It doesn't really matter. Just can't use 0, 0 because it goes through 0, 0. So this means 1 is greater than a quarter times 1, so 1 is greater than a quarter. Well, again, that's true, so I want to shade the side that doesn't include 1, 1. So 1, 1 is here, so I want to shade below the line. All right. These last examples are a little bit more challenging. You'll notice that they're not written in y equals mx plus b form. So we're going to be a little bit more imaginative about graphing them. So instead of graphing it with the y-intercept and the slope, we're going to graph it with the x-intercept and the y-intercept. So in order to do that, to find the x-intercept, remember y is equal to 0. And to find the y-intercept, remember that x is equal to 0. So everybody find the x-intercept and the y-intercept. When you do, you'll notice that the x-intercept, when I set y equal to 0, I get 3x is equal to 6, so x is equal to 2. And if I set x is equal to 0, I get minus 2y is equal to 6, so I get y, the y-intercept is negative 3. So if I graph those 2 points, 2, 0 is right here, and 0, negative 3 is right here. Again, this is a solid line because of that right there, so hopefully you can see that right there, a solid line. So I'm going to want to then use a ruler and put in the rest of the line. Once I do that, I need to pick my test point, and the process becomes the same. My test point here is 0, 0. So that's 3 times 0 minus 2 times 0 is greater than or equal to 6. So 0 is greater than or equal to 6. Well, that's false. So again, if 0, 0 is here, and I want to shade the false region, I'm shading above the line. Okay, next one. I'd like you to try this on your own. Everybody find the x-intercept, so you know that it's something 0, and find the y-intercept, so you know it's 0 something. Once you do that, graph that, and notice again that it is a solid line. Hopefully you got the x-intercept being 8, 0, and the y-intercept being 0, 1. I graph my line, and then I pick my test point. A great test point again here is 0, 0. So 0 plus 8 times 0 is less than or equal to 8. So 0 is less than or equal to 8. Well, that's true. So if 0, 0 is here, and that's the true region, I want to shade this time above the line. Graphing inequalities isn't very difficult because basically you're just graphing a line, and the only addition to it this time is that you're picking a test point. If the test region is true, you shade the opposite side. If the test region is false, that's the side that you shade. Not too difficult. Try it out for homework. Hopefully it goes well, and we'll continue on with the next note. Have a great day.